All right. And I did check. So I did do the cement testing, and um, the problems we have gone through did work out as we would hope. All right. Number 10. A company manufactures cylindrical metal drums with open tops with a volume of 2 cubic meters. All right, so let's draw a picture. Manufactures cylindrical metal drums. All right, so there's my metal drum. And we're told this has a volume of 2 cubic meters. All right. The metal used to manufacture the drums costs $1 per square meter for the sides. Okay, so sides. Drums cost for the sides $1. $1 per meter squared. $2 per square meter for the thicker bottom. Okay, and do recognize this cylinder is open on the top. So, be like an open paint can. $2 per square meter. Dimensions of the drum in order to minimize the cost. Okay, so we want to minimize the cost, so we're going to have to construct a cost equation. So the cost of building this can, well, that's going to be the cost of building the bottom with this side. So recognize the bottom is a circle, whereas the side we can look at as a rectangle. So if you were to cut this can down the middle and unravel it, you would recognize that the side is simply a rectangle. All right. So we should put some dimensions on this. So let's start by looking at the circle. And we'll give it a radius of r. Which means that, so recognize this bottom of the rectangle would have to be attached to the circumference of this circle. So the circumference of this circle is equal to the length or the width of this rectangle. So this is going to be 2 pi r, 2 pi r. Pi times d gives you the circumference. D for diameter, which is 2r. And we don't know how tall this paint can is going to be, so let's just call it h. So the cost of building this can, we need to consider the area of the bottom and then add the area of the sides. So the cost of the can is going to be the cost of the bottom plus the cost of the sides. Well, the cost of the bottom is $2 per square meter. So it's going to be $2 times the number of square meters. So you could look at that as $2 times the surface area of the bottom. Surface area, or I guess just area, might be a better way to look at it right now. Plus the cost of the side, or sides, however you want to look at it. The cost of the side is going to be $1 times the area of the side. that would be the area of the side. So a sub b for area of the bottom, a sub s for area of the side. So this is going to be 2 times the area of the bottom, well, the area of a circle is pi r squared, plus $1 times the area of the side. That's going to be 2 pi r times h. And that's because the area of the side really is the area of this rectangle. So this is the cost equation. And recognize we do have this cost equation in terms of r and h. So let's clean this up a little bit more. 2 pi r squared plus 2 pi r times h. And that will be the cost. So the cost is what we need to take the derivative of. It's what we're trying to minimize. Minimize the cost. So in order to minimize the cost, we need to differentiate this equation that describes the cost. Before we can differentiate, we need to condense down the number of variables we have, namely r and h. So the relationship between r and h is going to come from this volume. So we know the volume of this can has to be 2 cubic meters. So 2 has to equal, this is my volume. So the volume has to equal the base times the height. Well, that would be the area of this circle multiplied by the height component of that circle. So recognize the volume of this cylinder is the area of the base multiplied by the height of the cylinder. So 2 is equal to the area of my circle, pi r squared. It's the area of the circle multiplied by the height of the cylinder, which is h, from this description of the side. H would be the height. So 2 is h by pi times r squared. It seems most easy to solve this in terms of h and then use that back in here, because I mean, in my cost equation I only see h pop up once, and so it'd be most easy if I could simply rewrite this one h instead of rewriting both of these r's. So I get h is 2 divided by pi r squared, and this is what I'll substitute back in for h. So the cost equation now looks like 2 pi r squared plus 2 pi r being multiplied by h, which is now 2 over pi r squared. Let's do some housekeeping. So 2 pi r squared, pi downstairs, pi upstairs, r upstairs, r downstairs, and then 2 by 2, so that's to be plus 4 over r. Which, let's go ahead and rewrite this as 2 pi r squared plus 4 times r to the negative 1. And I'm simply doing that because I know I'm going to have to take the derivative. So I'll want to utilize the power rule. So I need to shove this r up into the numerator position as opposed to the denominator position. So I'm going to write this as cost with respect to, oh, not x, but rather r. So our cost equation is in terms of r. So let's find c prime of r. So we're going to differentiate with respect to r. Take the 2 down, multiply in front. 4 pi r, 2 minus 1 is 1. Bringing this negative down in front, multiplying it onto the 4, gives us a minus 4. And then r, subtract 1 off the exponent to get minus 2. Okay. So there's a few different ways I can do this, but okay, so recognize we need to set this derivative equal to 0 and solve for the value of r that makes this true. So I can immediately, I see a 4 in common, so I can write this as 4. So 4 times pi r minus r to the negative 2 equals 0. Okay. So I can divide both sides by 4 and then look at pi r minus r to the negative 2 is equal to 0. Right, if the product of two things is equal to 0, then one of these two pieces has to be equal to 0 for the product to equal 0. Well, 4 is never 0, so we simply get to focus on this piece being equal to 0. Okay. So I need to solve for the value of r that makes this true. I guess let's go ahead and let's see, we can factor out r. So if r is 0, we would get a solution, but having a radius of a paint can to be 0 doesn't make much sense. That'd be real nice if do I want to do that? See, I could pull one of those out and then I have that by that minus. If I take one of those out, gives me, I'd be at a minus 3. Okay, so yeah, let's look at it that way. Okay, actually easier. So we want to solve this for the value of r that makes it true. So pi times r is equal to r to the minus 2. So I've simply just added r to the negative 2 to the other side of my equation and then divide by r to see that pi is r to the negative 2 divided by r. Well, that's 1 over r to the 2 times r, which is 1 over r cubed. So essentially what we're looking at is pi is 1 over r cubed, which will give me r cubed is 1 over pi. A nice little quick way to, if you have something like this, recognize that's essentially a over b is equal to c over d. Well, if that's true, that's saying the top is equal to the top and the bottom is equal to the bottom. So if you ever have two fractions being set equal to one another, you can take both of those fractions and flip them to get b over a is d over c. It's a really quick and useful tool that you don't see very often, but I implemented it here because it would be really nice to see this r cubed go upstairs. So you could look at it as multiplying both sides by r cubed and then dividing by pi, which you would still end up with the same result. Similarly, well, this really is pi over 1. You can take both of these fractions and then flip them and set them equal to each other again, which in generality is listed here. So Lastly, to isolate r, we need to take the cubed root. So r is the cubed root of 1 over pi, which is 1 over the cubed root of pi. Cubed root of 1 is 1. So hence, we're looking at 1 over the cubed root of pi. What is that? So 1 over cubed root of pi. 0.68278. Okay. So a little bit over a half. All right, so that gives us r. Wow, this is getting to be a lengthy video. Sorry about that. So this is r, and we solved for the value of r. That would minimize our cost. And what are we looking for a solution? The radius. Okay, well, there's our radius. I would think they round to 1 decimal place. So recognize when you input these answers, you're going to want to enter it in as 1 decimal place, rounded to 1 decimal place. So we know r, here's our equation from before that links r to h. So now that we know r, we indeed know h. So we know the radius, we know the height. And then lastly, what is the ratio height divided by radius? Interesting. So once you have that figured out, mainly, once you have r keyed in and you have h keyed in, recognize to find this ratio, simply take the height and divide it by the radius. Height divided by the radius for this ratio. Okay, so this concludes the video on problem 10. It's a very nice optimization problem. It's kind of busy, so good luck, and I will see you on the next one.